All right, I think let's get started. Welcome to Build. Thank you so much for being here. I know this is a challenging time slot just after lunch, so double thanks to you guys. I hope you guys are having a good build so far. Just to make sure we are all in the right place, this is managing your ML lifecycle with Azure Databricks and Azure Machine Learning. My name is Premal Shah. I'm a program manager in the Azure Databricks team, and
Hi everyone, good afternoon. My name is Parashar Shah. I'm a program manager in the Azure Machine Learning team.
And just to kind of, if you guys are wondering, we are not brothers. We share the same last name, and we are from the same town, but we are very good friends. So just to clear that doubt, if you have it in your mind. How many of you have used Azure Databricks or are familiar with Azure Databricks? Just quick show of hands.
Okay, and how about Azure Machine Learning? Okay, automated ML? A few of you. Python?
Okay, awesome. So I think hopefully this talk will sort of be valuable to hopefully most of you. So if you look at the overall machine learning on Azure landscape, the way we think about machine learning is in terms of these 5 layers. So the topmost layer is the sophisticated set of pre-trained models that we offer our customers through the rich set of cognitive services which you can use to build end-to-end sophisticated AI applications. So this does not assume any kind of model building capability. You can just use them out of your box. The next 4 layers are speaking to the notion of custom AI. So this is where you want to build your own machine learning models. So you might want to use any tool that you're familiar with, any IDE that you're comfortable with, using a variety of deep learning and machine learning frameworks. So PyTorch, TensorFlow, scikit-learn, and then the set of services that help you really build these end-to-end sophisticated machine learning custom applications is Azure Databricks, Azure Machine Learning VMs, and what Parashar and I will talk about today is focusing on Azure Machine Learning, Azure Databricks, and how they help you manage your end-to-end machine learning lifecycle. And all of these layers run on the foundational layer of hardware infrastructure. So we have very sophisticated hardware in Azure, whether it's CPUs, GPUs, or FPGAs, and all these infrastructures are used for accelerated training and inferencing capabilities that you can leverage. What we have out of the box in Azure. So this is probably the best machine learning paper that I've ever read. It's my favorite. And when I started, learning about machine learning, I was under the impression that you build a machine learning model and then you basically throw any data at it, and out comes a beautiful model with beautiful set of predictions. How wrong I was, and based on my ignorance. And what we've realized is that machine learning, as you can see, is just a small small box in the entire scheme of things. So there's a whole bunch of things that's going on, and this is where you're spending like 80% of your time. You must have heard that statistic. So whether it's feature extraction, whether it's data preparation, once you build a model, how do you deploy it to a serving infrastructure? So how do systems help you achieve the whole end-to-end pipeline is what Parashar and I want to talk about, using Azure Databricks and Azure Machine Learning. So what is Azure Databricks? And some of you have used it, some of you're familiar with it. So basically it's a fast, easy, collaborative Apache Spark platform in Azure. And this is a unique Azure service because we have a partnership with the Databricks company, which actually are the creators of Spark. So what we have done is we have taken the best of Databricks and the best of Azure and sort of combined it to create this Azure Databricks first-party offering. So there are 3 key themes or pillars to the product. One is we want to fundamentally help you increase productivity. So what that means is that through collaboration, notebooks, through the ability for you to do DevOps, the ability for you to be able to create clusters without you really understanding the nitty-gritty details of the infrastructure, how can we help data scientists and developers be much more productive on this platform. The second is we want to bring to our customers the security and that Azure has, a security and trust that customers have come to expect of Azure. So how do we take Databricks and how do we integrate with Azure such that we continue to offer an end-to-end secure and trusted solution for our customers. And finally, being a big data system, you want to be able to scale it, without pretty much any limits. So how do we ensure that as you throw more and more data to it, it's able to scale linearly, efficiently, and you can manage your big data workloads. And of course, we make all of this easier through native authentication, through AAD authorization, and a bunch of other sort of needs that customers have come to us with. So if you kind of like just open the box a bit, so Azure Databricks primarily is of 3 layers, and the core system is made of the Databricks runtime engine, which runs about 7 to 10 times faster than open source Spark. So open source Spark has a lot of additions in terms of advanced caching, in terms of Databricks I/O caching, in terms of serverless computing. So your spinning up and spinning down of clusters is auto-scaled. That means you don't have to really, again, coming back to the productivity aspect, is you don't have to worry about managing these clusters. They are managed for you. They are scaled for you. So depending upon your workloads, the clusters spin up and down, which also has cost benefits. The whole platform is accessible through a set of REST APIs and CLI. So all of your end-to-end sort of processes can be automated using these APIs. Now, once you have the base in place, you want to be able to deploy your production jobs. So you want to be able to run pipelines, and that's where the job infrastructure comes into the picture. So how do you schedule jobs? How do you run jobs? How do you deploy these into production? So that's the layer which talks about the deployment and production workflows. And finally, if you look at the personas, we have data scientists, data engineers, and business analysts. And what we're trying to do is blur the differences between the two. So typically, data engineers do a certain kind of function, data scientists do a certain kind of function. And through the platform, we are trying to blur the differences such that through all these added capabilities, the data scientists and data engineers work together. And business analysts can access the system to do BI reporting. So on the left-hand side, you'll see, just like any big data system, we want to integrate with the rest of the Azure infrastructure. So it has the ability to take inputs from all these different systems, different storage systems, different warehouses. And then finally, once you're done with your big data analysis, how do you sort of expose it to downstream BI tools, warehouses? How do you build models in Azure Databricks and then deploy them such that your line of business applications can start using them? So what is Azure Machine Learning Service? Again, three key themes here. One is we want to make data scientists be productive. So the idea is that whichever IDE you are comfortable with, you can use that to leverage Azure Machine Learning services, through an SDK, through a Python SDK. So when you're building out a machine learning model, it's not just about training the model, it's about how do you experiment. So how do you come up with the best model? How do you make your training processes reproducible such that when you arrive at a particular model, you know how you arrived at that particular model. So the whole rate of experimentation using different compute infrastructures is possible through Azure Machine Learning, and Parashar will walk you through some of that in detail a little later. And then finally, I think the most powerful concept here is that you can deploy, manage, and monitor your models using Azure Machine Learning services. And typically in a machine learning lifecycle, the end mile of deployment is the most sort of difficult and painful part, in terms of like once I have a model, how do I make it usable throughout the enterprise? So that's where Azure Machine Learning also is very useful. And again, Parashar will walk you through some demos. So if you look at the machine learning lifecycle using Azure Databricks and Azure ML, there are kind of 3, and this is something that you must already be familiar with. There are 3 main sort of components to building an end-to-end ML lifecycle. The first one is, you have to prepare data. So coming back to that slide which I showed you earlier, 80% of your time is used in sort of this data preparation phase. And we're going to show you how Azure Databricks helps you to prepare that data. Once you have the data, then you want to build and train your models. So you want to use a variety of training frameworks. You want to pick the best model. As you're building your model, you want to do experimentation. You want to make sure that your model is reproducible. So all those facilities and how Azure Databricks and Azure Machine Learning helps you to achieve that, we will go into detail on that. And then finally, as I mentioned, how do you deploy, manage, and monitor your models? And how do you deploy models in different surface areas? So how do you deploy it on the cloud and on the edge to make it useful for downstream applications? So in data preparation, where Azure Databricks really shines is that, as you guys might know, Spark has more than 50 connectors to different data sources. And when you're building machine learning models, you want to make sure that you're leveraging as many data sources as you can, as many data formats as you can, because you might have some legacy data hanging around in different formats, in different systems. So Azure Databricks really helps you to collect all this data together and be able to do large-scale processing on that data for you to then be able to build machine learning models out of that data. Our integration with Azure Data Factory is I think, a very cool integration, and what it allows you to do is able to take your data from legacy systems, so whether it be Oracle or whether it be Sybase or HANA or whichever systems you might have, and then sort of move that data to the cloud, and then you can use Azure Databricks to then process this data in a large scale and a meaningful way for you to then to be able to do machine learning modeling later on. In the build and train phase, you have a variety of frameworks to choose from. Today, you can use so many different frameworks to build machine learning models, and we want to make sure that we support every framework. So you use Azure Databricks notebooks to then use these frameworks to build models. And then finally, you use the capabilities of automated machine learning, which is a cool demo that Parasha will show you as to how you can use automated machine learning to really help pick the best model for you in Azure Databricks, so that you can then deploy that model and you can use. And we'll also talk a bit about MLflow and the Azure machine learning integration, which is something we released at Spark Summit last week. And then this is to me is really the most powerful thing, where once you have your model, how can you then deploy it? So the way it works is in Azure machine learning is you first of all, once you have a model, and it could be any model, it could be your own model, it could be a model that you've created, again using any kind of framework, and then you register the model in the registry, and then you have a score file, which is an application that then uses that model to score any new incoming data. And then you can deploy those models either on the cloud or in Azure Kubernetes Service, or on the heavy edge or on the light edge. So you can deploy it, a heavy edge is like a car, and the light edge is like a sensor. So the idea is that once you have your model, how you can leverage it and deploy it to different surface areas for you to be able to then start inferencing on new data that's coming in. And this is very, very useful for IoT type scenarios also. And the last mile really is, once you deploy your model, how do you know that your model is performing well? So monitoring of models is also really, really important, where you might want to check to see if your model is behaving the way it's supposed to as new data is coming in. Is your model able to predict as accurately as you had expected? And if not, how do you go back and retrain your models and then redeploy so that you are getting the business value out of whatever you have built? So I think I'll hand it over to Parashar, who's going to walk you through a set of cool demos. Over to you.
Yeah, thank you, Premal. And so what Premal explained is how the regular ML life cycle works, right? So you start with data preparation, you pick and choose a model, and then once you are happy with the model, you start deploying it, right? So the idea which I'm going to talk about now is there are different ways in which you can do this. So depending on the scenario or the comfort level of the team, you can pick and choose which one works for you. So in Azure, just like a lot of services, you have multiple options, and it always takes a little bit of effort in order to figure out when to use what, right? So we are going to try and simplify it for you. And if you still have questions, the mic is there at the end, so we can talk about it. So let's walk through this example of manual machine learning, right? In which case you are trying to predict the price of a car. So I'm going to make it a little bit more interactive. So how many people think this is a classification problem? How many of you think it's a regression problem? Okay, most of you, that's great. Yeah, so it's a regression problem, right? Because you are trying to predict a number instead of just saying a yes or a no or a true or a false. So if you are to develop this model from scratch, what are some of the features that you think are important? How about brand? People think brand is important if you want to predict price of a car? Yes, make, model, things like that, right? And then, like, after you pick the features, you start with a particular algorithm. So you could start with classical machine learning, something from scikit-learn world, or you could start even with deep learning if you want to make it very fancy, right? But in either case, you pick and choose an algorithm. And then you set certain parameters. Now, you could go with default parameters, like every algorithm would have certain default parameters, but normally you are required to tune it. So the idea behind this is when you start with it the first time, you might get a result, and in this case, say for example, you get a model that is having an R square of 0.3, so 30% kind of reasonably, okay, let me put it. Is it a good model or a bad model? How many of you think it's a good model? How many of you think it's a bad model? Okay, and why? Is it like flip of a coin thing, right? I want to make it more interactive, but all of you don't have a mic, so let me just, but a random flip of a coin would have given you 50% probability, right? So you don't need to do machine learning if the model is giving you 30%. So what you do is, now you iterate. So in this, you probably change the features. So you bring in more data. You probably join some data sets. And this is to Premal's earlier point where he said 80% of the time actually goes in preparing the data, right? So you might have a machine learning problem, but do you have the right type of data to solve that problem? So you probably bring in more data. You can even change the algorithm, change parameters, and you keep on doing this. And finally, you get a model which actually is good. And by then, you would have probably spent some weeks or months, and of course, a lot of money and time, right? So automated ML is trying to address this area. So the idea behind automated ML is how can we augment the productivity of a data scientist? So at least in the Python version, which we are going to see today on Databricks, we are not trying to replace a data scientist, but we are trying to augment the workflow of a data scientist. And how do we do that? It's essentially you give us what problem, or you tell us as in the service, you tell the service what problem you are trying to solve. And then you define the constraints around it. So constraints could be, like say if you are thinking of that this machine learning model is going to help you save $1,000, for example. So you do not want to spend, like say, maybe more than $100 on training it, right? So you're looking at 10 times the ROI on that, for example. So you translate that $100 in terms of the training time that probably you would want to spend. So these are some of the constraints that you can give. That, okay, I want to do a classification, or I want to do regression or forecasting. That is what we support right now with automated ML. And then I want to spend only 10 hours in training with this much of compute. So in the demo that I'm going to show you now, it's going to be Azure Databricks as your compute, but you could use other compute as well. Okay? But these are examples of the constraint. And then you can also give, like you can whitelist certain algorithms, you can blacklist certain algorithms if you know certain algorithms perform better, but you don't have to manually pick and choose the algorithm. We do that for you. Now, we just don't limit ourselves to selecting an algorithm. We also do pre-processing, and we also do hyperparameter tuning. So it's multiple things that we take care of as part of automated ML. Okay? And so it's more of a, think of a machine learning model that we have trained with open data sets in order to help you do machine learning. So that's how you have to think of it. Okay? Once you have that, then essentially you can deploy the model the same way that Premal showed you, that take it, register it in Azure ML, and then deploy it in a Docker container. So let's go ahead and look at the demo. And only a few of you raised hand for automated ML. The reason I'm not going very deep into it is also there was a session in the morning which my teammates shared, so 8:30 a.m. So in case you want to look at the whole session, you can go through that as well. But if there are questions later, let me know. Now, we are going to start with the Azure portal. How many of you know Azure portal, have seen it, have access to it? Okay, all of you, that's great. Okay, so the first thing that, because we are going to run automated ML on Azure Databricks, the first thing that you need is an Azure Databricks workspace. Okay, so
I have a quick question here.
Yeah.
Is you said automated ML on Azure Databricks.
Yeah.
Why is Azure Databricks good for automated ML? Is there a specific advantage you get running on Azure Databricks, or?
Yeah, so that's a good question, thanks. So the reason Azure Databricks is performing very well with automated ML in addition to the other compute is, like, there are a lot of customers that we work with who already have their data in Databricks. Okay, so either it could be in DBFS or they have connectors which are there. So they don't want to move their data outside, or they have Databricks as part of other things. So they want to stay within the Databricks notebook, but they still want to do automated ML, so they don't want to do manual machine learning. So that is one. And when using automated ML on Azure Databricks, we also leverage some of the Spark technologies, so you can actually do parallel training, which is there, and you will see that in the demo. Thank you.
Thank you, Bhash.
Yeah. So let's first start with creating an Azure Databricks workspace. So I already have it pre-created, but I'll just show you for people who haven't seen it before. So the workspace is where essentially your Databricks compute, or the cluster, and your notebook will reside. Now, how many of you understand notebook? Jupyter, or, okay, that's great. So it's the same IPython notebook which is there. Now the environment is a little bit different than Jupyter, but you start with just creating this workspace by providing the location, resource group, and the subscription. You can also deploy this cluster in your own VNet if you want to. Okay, I'm not going to create the workspace because I already have it, but once you create it, you'll see something like this, right? So it loads with this home page, and then it's going to show you different options on the left. The first thing that you would do, you or the IT department in your company, or anyone who has the permission to create clusters, can create a Databricks cluster in the runtime. Now you can select high concurrency, you can select the latest runtime that you have, Python version is 3, and you can also select auto termination if you want to. So basically when you're not using the cluster, it will shut down automatically, right? And in this experiment, at least I want to run training in parallel. So to your earlier question, I'm going to fix the number of workers. Now you could give any number of workers based on what you want. The preference for using at least AutoML or automated ML on Databricks is that you use memory optimized VMs, because some of these things are memory intensive. Of course, you can use CPU, but the preference is that. And we have good documentation as well to talk about it. So basically how to set it up. So if you go to the Azure Docs, you can actually go through all the details in terms of all the config that is required. Okay. Now, after you have created the cluster, what you do is just one step, which is install the SDK. So this is the AutoML SDK, and you can install any Python library, and it's very straightforward that you select the library type, and then you just give Azure ML SDK, AutoML Databricks. So this is how you would do that. And once you have that, this library is available on this cluster all the time. And every time the cluster restarts, you can get the latest version. Now you can freeze it by doing equal to a particular version, but otherwise every 2 weeks we release a new SDK version and you get the latest. And it could include bug fixes, it could have new features, etc. Okay, but it's that simple to how to get started with it. Now, once you have that, you go ahead and select your notebook. So I have this notebook. Now, for people who know Jupyter, this environment is similar to Jupyter, except that this is serverless. So with Jupyter, whenever you want to read your IPython notebook, you have to actually spin up the server. In this case, you can read the notebook and the cache data, even if the cluster is shut down. In my case, I already have a cluster running, and I have already attached it. So I'm going to go ahead and now run an automated ML experiment. Now, in this experiment, what we are trying to do is to predict the remaining useful life of a turbofan engine. So this data set is a real-life data set. It's from NASA, and this is basically sensor data which is there. And we are going to figure out, based on all the sensor data information, how many days before I need to do maintenance of an engine. Now, if you do it too early, then it's downtime, right? So it's loss of revenue. If you do it too late, then it is risky. So you want to find the optimum thing. And we are going to use automated ML on Databricks to do that. So I have the cluster and I have the SDK installed. So I'm going to download the data set over here. I have already downloaded it. It's around 100 MB. It's a demo data set. But the first thing I do is to derive the column, so label column, which is the RUL column. And that's the one that we are trying to predict. Other than that, I don't have to pretty much do anything, like just provide the data frame with the right kind of data. And then I'm going to use the Azure Machine Learning workspace and submit the training experiment to it. So the input to automated ML is a data frame. You basically have a pandas data frame, and you'll see that it takes that data frame in the form of a data flow, and then does all the training, pre-processing of the data, selects the model, and also does hyperparameter tuning, all three things. Okay. Now, how many of you know Azure Machine Learning Workspace? Because many of you raise your hand for Azure Machine Learning, sir. Some of you. Okay, so let me explain what it is. But Azure Machine Learning Workspace is a single place or a central place for your team to collaborate. Now, if you recall what Premal mentioned earlier, that there are 3 different phases, right, in a traditional machine learning: that preparation of data, training, and then the deployment. Now, oftentimes, the data scientist team who is actually who are training these models are not the same who are probably deploying it to production. So there is a separate DevOps or a software development team who is actually doing the deployment of the model. And when I say deployment, I mean creating a web service, an HTTP endpoint or something like that, so that it can be consumed in your smart application, right? So, then if these different teams, if they want to collaborate with each other, it becomes tricky. And that's where the Azure Machine Learning Workspace comes in. So this workspace, it's different from the Databricks workspace we talked about earlier. So the Databricks workspace is having your cluster and the notebook, whereas the Azure Machine Learning Workspace is having all your experiments, all the trained models, different versions, and all your data sources and everything. Now, the relationship can be many to many, because you can use Azure Databricks for machine learning, but you could also use it just for analytics, right? So, and similarly, with Azure Machine Learning Workspace, you can use Databricks for doing machine learning, or you could use AML compute or even your local laptop in order to do that. So it's a many-to-many relationship. But we are launching something new today, and that is the capability that we have integrated these 2 workspaces. So either you can create the workspace from code, like you can write Python code to create this workspace, and I'll show you that. Or when you have your Databricks workspace, so this is my Databricks workspace which we created. From there itself, now I can create an Azure Machine Learning Workspace. And when I do that, it links itself to this. So we are tightly coupling it. And the reason we are doing this is to decrease the time it takes for you to get started with machine learning, right? So it's simplification of this whole process. So that's how it is. And now once you have the workspace, either created from Python or from the portal, you just call that workspace and submit the experiment. So here I'm submitting an AutoML experiment, as you can see. And the configuration is pretty much straightforward. It just takes what is the experiment type. So basically whether it's classification or regression or forecasting, and then the metric. So we support certain metrics for every experiment type. So it could be, for example, accuracy if you are doing classification, or it could be your root mean square error if you are trying, so basically minimizing the error if you are trying to do regression.
So Prashar, I have a question, maybe audience already has a question, but you mentioned about pandas data frame as the input to AutoML.
Yeah.
So what if your data is, because typically in Spark, Spark data frames, can span across multiple nodes. Pandas is is one node. In your experience, is pandas data frame enough for you to be able to solve these problems, or do you have any other guidance around that?
Yeah, so that's a good question. Thanks, Premal. So the question is, when does pandas data frame not work, if I can think of, right? So absolutely right. So the thing you have to note is when you are providing this data frame, you are providing a featureized features. You're not providing raw data. So as a domain expert, you know that certain columns are important. Now, we do pre-processing. So if it's a string column, for example, or a categorical column, we will do one hot encoding as part of the AutoML process, for example. But then at least you need to provide the right columns to start with from the domain perspective, right? So what we have seen is when you look at the featureized data, the data set size decreases. So even though you might have terabytes of raw data, when you actually get featureized data set, it's significantly smaller. And then we also support subsampling. So it's like, as long as your data set is a representative sample of whatever problem you are trying to solve, you can get good results. So these are some of the things. And we do have plans to support even Spark data frame. It's not there right now. So right now it's pandas. Now, coming back to the experiment, this is what you would do. So basically, when you are running it on Databricks, you provide how many concurrent iterations you can run. And this primarily means that how many worker nodes you have. So because this training is happening in parallel, right? So automated ML is looking at your data set and trying to do pre-processing, model selection, and hyperparameter tuning. It can do this in parallel on each worker node, and that's what is happening. So if you have if you have 8 worker nodes, it can do 8 parallel trainings, and that's how you have to think of it. There are other parameters like exit score and things like that. So that's it. So it's that simple in terms of the config. Now let me submit the training. So I'm going to submit it, and Murphy, as long as he is okay, it should be fine. So let's see. So I'm going to submit the experiment, and what is happening right now is it's going to take the data set which I showed you earlier, and then going to train it on this Databricks cluster. So we are not using the driver node, but we are using the worker nodes, right? So that's how it happens. And while it's running, I can show you a result from my previous training, but okay, let's see this. So the first step it's going to do is create the setup run. Setup is basically all this pre-processing and things like that that I mentioned, and then it's actually going to start the training. So certain machine learning algorithms expect your input data in a certain format and certain, so we figure out all those things for you as well, okay? And just to give you an idea in terms of what other pre-processing we do, we have a very nice documentation. So where did it go? Yeah. So we do some of these things like cardinality dropping and missing value imputation, and also generate additional features, like say if you have date columns and things like that. And we keep on adding more capabilities in here.
And Prasha, one question I have is that what kind of frameworks are supported in automated ML? Like if maybe you can give us an idea of the list of algorithms that you support, it might help us understand.
Yeah. That's a great question. So on the algorithms, when using automated ML on Databricks or any other compute, we actually support these algorithms which are there. Now, if you have your favorite algorithm, you can actually whitelist it, or if you know certain thing doesn't work, then you can blacklist it. But this is how it is. Okay. So and we keep on again adding things to it, but this is the current list. Let's go back to the experiment which we created. So what is happening here, I'm submitting this from Azure Databricks to my Azure Machine Learning workspace, and then it is doing all the training, okay? And the training is happening in parallel. So, yeah, where did it go? Okay, so I'll just go back. Yeah, and the training is happening over here, and you can see running. So what it does is now it is using my worker nodes and actually starting this training, and you can see which algorithm I have picked. So let me zoom it out a little bit so you can see that. But you can see the algorithm. You can also see the preprocessor that I'm using and the associated metric. So now this is happening. I had submitted 30 runs. So it takes a few minutes, I think around 10 minutes. So we are not going to spend so much time. but I'm going to show you a pre-run result from the same workspace, and I just ran it a few minutes back, but this is what it is. So Databricks was the compute, and Azure Machine Learning SDK running on top of it using automated ML capability gave me the result, and it told me that this run number 29, which is using stacked ensemble model, is your best model. And it did the pre-processing and all those things, okay? And then I can now go ahead and take this model and actually start deploying it. So this is the, I can also look at hyperparameters if you want to, right? And then I'm going to start deploying it. So the deployment flow is, again, you are training using Azure Databricks, but you may not want to or do not want to deploy it in Azure Databricks because this compute is running all the time, but you probably want another scalable compute which is taking your web service. So you take that AutoML model, but then deploy it to a Kubernetes node or a Kubernetes cluster, and we help you do that. So there is a Docker runtime which we help you create, and we manage the service for you. So if you're deploying it to Azure, then you get to see all the metrics and everything around it. Okay, so that is how it works. And the Docker container is pretty much straightforward. Like you just tell us how much memory and CPU you want, and then with just one method call, like saying deploy from model, we will do that for you. So that's how the deployment happens. I already have it pre-deployed, so let's see what it's actually predicting. So this is going to be my web service. And then I'm going to see if it predicts well. So I'm sending it some data, okay? And my actual data was saying that my remaining useful life of the engine was 191 days, okay, in my tests. And the result that came out from the AutoML predicted model is 196 days, which is reasonably good, right? So we spent like 10-15 minutes on submitting the training. Now, this is a sample data set, but this notebook is available on GitHub or on our GitHub, and you can actually modify it to adapt it to your scenario. So because predictive maintenance could be a common thing that you would have. Okay, so this is how we saw that how to run one part or automated ML on Azure Databricks. Now let us go to the other one, which is MLflow. So how many of you know MLflow? Only some of you. Okay. So MLflow has capabilities to do tracking of your experiments, so whatever you are running, right? And it's an open source project. And then it allows you to create projects, and then it also allows you to train the model. So this is just an alternative way that we are switching, because like we started the talk, we wanted to keep it open so that we wanted to help you decide rather than we deciding it for you. So that's how it is. Yeah.
So Parashar, there's one thing I'm not very clear on, is, so you're saying that MLflow is the API, and then Azure Machine Learning is the engine underneath MLflow. So why would I want to do that, or what's the benefit for me to do that?
Okay, yeah, no, that's a good question. Why would I want to use MLflow? And so probably one thing is, of course, I need to earn my bread. But in addition to that, what we heard from customers is they like to use open source, right? So rather than competing with open source, we thought of embracing it. And basically, it's just another set of APIs, but the underlying is still the same Azure Machine Learning SDK and the Azure Machine Learning workspace that I showed you earlier. So the capabilities like the experiment tracking. So you saw in the portal I showed you the tracking of experiments whenever you run it, and the projects which are there, and the deployed model. So what you saw earlier in the automated ML example, that the model gets deployed. So when you're using MLflow, now it can use those things as well. So the deployment piece was there for around 6 months, for at least around. But what we launched last week, and you touched upon it earlier, was at the Spark Summit, we launched that Microsoft is officially joining the MLflow open source project. Okay, so our team is officially a part of it. And when you use MLflow in Azure, you can leverage the same machine learning workspace. And the idea behind this is you can use MLflow for things that you like, and you can use other Azure machine learning capabilities, but independent of which API you use, all your training and deployment can still happen from the same workspace.
You can get the best of both worlds.
Best of both worlds, and it's a central place, so you don't have to worry about it. Okay. Now let's go ahead and look at the demo for this on how to use that. So in this case, I'm going to show you two demos. So one is using MLflow in Azure Databricks, and the other is using MLflow in a Jupyter Notebook environment. So it's very straightforward to start with this. So basically, you have your Databricks cluster, okay? And in that cluster, basically what you do is you install the library as a pip installable library, and then on the Azure Machine Learning workspace that you create, right? You just have to use 2 lines of code, and I'll show you that. But it's as simple as this, that you just set the URI. You don't have to do anything else. So our goal is to meet you where you are rather than you having to learn something new. So with this 2 lines of code now, you can, whenever you are running that MLflow experiment on Azure Databricks, is actually logging all the results to the same Azure Machine Learning workspace. Okay. So now in this demo, what we are going to show is the MNIST example. How many of you know MNIST? Probably at least most of you, right? Yeah, so it's a traditional data set where you have, the original problem started with trying to identify numbers, like the zip codes for postal services, right? And then it became a data set where, based on handwritten numbers, you are actually trying to predict which number it is. So in this case, this is a deep learning example, okay? So another flavor. So earlier we saw automated ML, which was using certain frameworks. Now we are going to go into the deep learning part of it. Again, we are still in the training domain and then deploying, but we are going to use PyTorch on top of Databricks, and we are going to use MLflow for tracking your experiments and MLflow for deployment. But please remember, when we are doing that, it is still leveraging the same Azure Machine Learning service and the Azure Machine Learning workspace because of the integration that we have done. Okay? So in this case, I have an experiment that is created, and this is all PyTorch code where I'm bringing in the data, and here I'm logging the metric. So I'm trying to log the loss, which is associated with every experiment. I'm going to run this, and this is going to leverage this same Databricks cluster. So this is just like automated ML, which was running on your Databricks cluster. In this case, MLflow is doing PyTorch training on Databricks cluster, logging through the MLflow API, but it's actually getting registered to the Azure Machine Learning workspace. Okay, so let's see how it does that. And I have this experiment open. So this one. So this is my workspace, and when it finishes the training, I think it's just starting. Yeah. So yeah. So when it finishes the training, you can see the actual logging happening in the same workspace. So this is the same workspace where in which I showed you the automated ML experiment as well, right? So there was this automated ML experiment which did not use MLflow, and then there is this PyTorch experiment where I'm using MLflow. So now think of it in your own scenario in your organization where there are different teams of data scientists. They probably want to use different frameworks. For example, one team might want to use automated ML, another team might want to use deep learning with MLflow or even Azure Machine Learning SDK, but you want a central place where all the results are logged or all the models are trained, right? So this is allowing you to do that now. And yeah, so the epochs have started training, and I think we should be able to see the results in real time if I'm not, if my demo gods are with me. So that's always the nervous moment. Okay, so cool. So it's running here, and I'll just minimize this, and you can see epochs getting updated in real time. Okay, so now it's actually doing that training, and it takes around 2-3 minutes, so I'll just leave it there, but this is real-time logging of that from MLflow to Azure Machine Learning web service. The second demo that I'm going to show you is a variation of that. So in this case, what I'm going to show you is you still want to use MLflow because probably like I said, you like open source or something else, some other reason for which you want to be in MLflow ecosystem, but you want to leverage Azure Machine Learning Service and the workspace and the SDK. But you don't want to use Azure Databricks notebook. So in this case, I have a Jupyter lab, which is there, or you could have the same approach even in regular Jupyter. I have installed MLflow on top of it, so it's again a pip install, right? And I'm using the newly launched notebooks in VM. So how many of you know the new product we launched this week? Only a couple of you, yeah. So this is basically a hosted experience for Jupyter Lab. So the way it works is in the same workspace that I showed you earlier. I'm going to go back. You see on the left-hand side, there is an option called Notebook VMs, okay? And you can actually have this VM and you can pick the VM type. So you can have a CPU or a GPU-based VM over here. You can pick any of the VMs. And this is going to be your server. But we manage this server for you. So the outcome is basically a Jupyter Lab-based server which is running. And then now you can enable it for people to use it. So this is what we launched this week in private preview. And I already have MLflow installed as part of it, along with that. And it comes pre-installed with Azure Machine Learning SDK, so you don't have to do anything. Now, the difference here is because this is not a cluster environment, right? This is a single virtual machine, a single VM node, which is now running that Jupyter Lab, but we manage it for you. So instead of like running the training on that node, we are actually submitting it to a remote compute. So now if you contrast the two scenarios we talked about, so in the previous scenario, for PyTorch, we leveraged the same Azure Databricks cluster. We had the Azure Machine Learning SDK installed. And in this scenario, we are using Jupyter Lab, but now we are submitting the training to a remote AML compute cluster, which is an alternative. So if you are Spark, probably you stay in Databricks. If you are Python, probably you want to use AML compute. So these are two options, like I said. But the end results are still the same, because even this one is going to log your results in the same machine learning workspace, and you deploy it from the same, okay? So we are going to see that. So the code remains exactly the same in terms of the actual training, but what changes is this, where instead of training on the compute, I'm going to show you, yeah, it's a little bit of scrolling, but this part. So let me zoom it so people can see at the back. But this part. So I have a compute that is provisioned, and this is what is going to actually take the training. So we are going to run it, and again, I'm at the mercy of demagogues, but we'll see okay, how it happens. So I'm going to run this, and then I'm going to do run. So it's now what it is doing is it is taking that MNIST data set, and because the compute was created, it is submitting it. If the compute doesn't exist, then it will create the compute for you, and then submit the training and shut down the compute. So you can set that minimum node 0, maximum node x. So based on utilization, it will go up and down, okay? So now in this case, let's see what happened. I submitted the training. It takes, yeah. So I have the training now. And when I open this, it no longer goes to the portal, but we brought the portal inside your Jupyter Lab extension, inside your Jupyter Lab environment itself. So now you can see in real time the same training that you saw earlier. Now it's happening here, and you're able to see the results here. But you go to the Azure portal, and you can still see the same. So it's integrating everything. So now your ML lifecycle of data preparation, which probably started with Azure Databricks for doing the data cleanup and processing of your data, joining, and then using training with either AML Compute or Azure Databricks, but the underlying is still Azure Machine Learning SDK. Now it's generating models which are all logged in the same workspace. Okay? And once you have that, you can actually now deploy it from here. So this is the same approach again, right? But instead of now the automated ML or some manual trained model, we are now deploying the same model. And rest of the flow remains the same from the workspace. So you register the model, create the Docker, and then deploy it to AKS. And the result, let's see what it predicts. So I'm going to, so in the MNIST data set now I have 1,000 images, okay? So I'm going to pick image like say it's today's date, right? So 5/8, for example, or maybe 5/08. How about that? Okay, so I'm going to just take the image number 5/08. Let's see what that image is. So that image is 6. So this is the image in the actual data set. And I have this model deployed using Azure Machine Learning. We are going to see what it predicts, right? So it predicted right. Now, if my model had done some goof up here, it would have been a terrible model because the research that has been done on the MNIST data set, people are predicting like more than 99% accuracy. So, so yeah, but it's doing well. Now, you can see the same result in the workspace as well. So if you go to the workspace, which I had earlier, the same experiment should be running here. So this is the PyTorch example. And yeah, it completed just now, but this was the script run. And now you can see the same results and epoch and everything. So one single place to do everything. So let me summarize what we saw in the demo. Thank you. So in the 3 different demos that we showed you, essentially we showed that how to have your entire end-to-end machine learning lifecycle, right from using Databricks for data preparation, using automated machine learning, or manual machine learning training to train the model. And again, we saw options like either using Azure Databricks as the compute, or even using AML as the compute. But whichever approach you use, you are still tracking, logging, registering, whatever you want to call it, in the same machine learning workspace. And then you are ready to deploy it to production from there, right? So if you don't know Docker, like I don't know Docker, I could still deploy the model. So yeah, we simplified for you. And once it's deployed in Azure, you can actually track the metrics. So the latency, how many users are actually hitting the web service, and the web service scales automatically. So if, like say, I work with retail customers many times, so Black Friday and all those things, right? So then they don't have to worry about it. They can have this configuration set up. So the service will automatically scale in few minutes. So scale up or scale down based on the traffic that is hitting it. And you can actually even do drift analysis. So once the model has been deployed over there, you can actually have triggers so that you know when to retrain it. And you can also automate the retraining part by integrating it with pipelines. So we are not covering that part. That was another session that was there, I think, yesterday or today. But how to orchestrate this entire workflow. So in terms of lifecycle, that's it. So this is what we have in terms of the different approaches when using Azure Databricks. And we were trying to answer the question that, okay, is Databricks competing with Azure Machine Learning SDK? Because I get this question a lot when I work with customers. So I hope you also probably agree with me that the answer is no. We are trying to actually leverage that as the compute, and we are integrating it together. So it's more of a better together story rather than one versus the other. So you can use both. So I'll hand it over to Premal to summarize, and then, yeah.
Thanks, Parashar, for a great set of demos. So I think in summary, the few things we want you to take back with you, I think the first thing is the better together story between Azure Databricks and Azure Machine Learning. As Parashar said, it's not an either or, it's really a combination that sort of makes you build these compelling applications. The other thing is that the importance of this Azure ML workspace as the single point where you're sort of collecting all your experiments and all your models. So for all of your ML in Azure, the Azure ML workspace is really the central place where you're collecting models and registering models throughout your organization. So that's kind of the central piece, and that's a great value add of Azure Machine Learning here also. And that's why the MLflow Azure Machine Learning sort of integration makes a lot of sense there too. So the key updates is, the good news is whatever Parashar showed you in automated ML and a bunch of other new features are now GA, so you can go ahead and use it, you start using it, start giving us feedback. MLflow with Azure ML is, we just released last week at, I think last week or week before last at Spark Summit. So again, you will see a lot of developments in this integration. So we are continuing to strengthen the better together story across all these products, so that again customers get the benefit of all these working together seamlessly. And the last thing is the Azure Machine learning workspace integration with Azure Databricks workspace. So a lot of our customers are using Azure Databricks, and they want to use Azure machine learning. And what we are trying to do is make that experience really, really simple. So right now, if you use it, with this integration, you will notice yourself, for those of you who have already used this integration, that the whole story becomes much more simpler. You have to write fewer lines of code. You can get up and running with Azure ML much quickly, due to this integration. And we'd love your participation in the private preview for all these new features. So please register, and then we can definitely reach out to you and sort of help you onboard onto this. So
I just had one point to add. So automated ML, it has capabilities like model explainability and forecasting and all those things which we did not show in our session, but that's why the drum roll is there. Basically, when we say GA, now it's production ready for you, and you can leverage all the features on Azure Databricks, which was not the case. So we were in preview from past 5 months. December is when we launched the first time the public preview for automated ML on Azure Databricks. And at build this week, we are doing GA. So it's production ready for you with all the integrations available. And the remaining 2 features are the ones for which you need to enroll for private preview. You need to provide your Azure subscription, and probably you need an NDA if you don't, just so that. But yeah, thank you.
There's some additional resources that you can leverage to sort of know more what we have just covered. And finally, any questions from the audience, anything that we can help answer? I think you'll need to come to the mic so that since it's being recorded.
Yeah. So we still have 5 minutes, so yeah, any questions, welcome.
And we'll be outside after the talk. If you guys have more questions, we're happy to.
Sure. The mic, can the question? Tap it. No, it's not.
Is it on?
Yeah.
Oh, yeah, yes, yeah. Thanks.
Yeah, so normally the way we think, the question is the MLflow with Azure Machine Learning and the integrated workspace, which are in private preview, when will it go GA? Is that correct? Yeah. So normally the way we keep it is we try to gather your feedback, and then few months is what we look at. So to give you an example, automated ML on Databricks, it took us 5 months to GA. I'm hoping this would be shorter, but it depends on how feature complete we think we are and how good the customers are thinking. So normally it's less than 6 months, but it varies. Yeah.
So let me repeat the question for the audience. I think what you're asking is, there's still some confusion between MLflow and AML workspace. Is that kind of a question? So I think I will start, and then Parashar, you chime in. So what the idea is that MLflow is the API. So MLflow also does experimentation, but underneath the covers, setting those 2 parameters is AML sort of helps you to log all the MLflow, the experiments in this central AML workspace. So the idea is that you can, if you like MLflow, if that's what you're used to, you can use it from anywhere you want. So you can use it in a desktop, you can use it in other systems, but then using AML, you're able to write to the MLflow API, but all these runs are collected in that central AML workspace for you to be able to leverage. I mean, you can add.
Yeah, no, this was great. And I just want to add, we showcased MLflow because we were talking about Azure Databricks, and a lot of Azure Databricks customers ask us that what is the MLflow story. Otherwise, everything that we showed can run purely with Azure Machine Learning SDK. You don't need MLflow if you don't want to. We just showed that, okay, if you are using MLflow, you can still leverage Azure Machine Learning. So that was it. Okay, so the question is, when you had the AutoML trained model, does it keep track of the pre-processing? Answer is yes. So if we did some pre-processing as part of the training, you don't have to worry about in the scoring file. when doing the deployment. But if you did it something outside of what AutoML does, you have to add it. But whatever we did, we take care of it automatically. Yes, it gets applied to the model automatically. That's right. Yeah, thanks.
Thank you. Any other questions? This one? Yeah.
Yeah, so this feedback link, it's not just for our session. It's for overall Azure. So you can give us any feedback. We monitor it. It could be features. It could be bugs, whatever you want to. So we have that.
I think one link that we don't have there is the Azure Databricks documentation. So it's docs.azuredatabricks.net. It's really simple. So that's where all our Azure Databricks documentation is. So have a look at that on sort of how to
We have good documentation. So if you search for it, you'll get it. Yeah.
What are the options to deploy the Docker container into? By default, where do you support it landing into?
Sorry, could you repeat the question?
When you have the Docker container built out, where would it eventually land into? What kind of tooling do you support? Do you support it going into AKS?
Yeah, okay.
Or is there anything beyond AKS?
Okay. So the question is, whatever Docker container the machine learning service creates, which all places you can deploy? Yes, so you can use the same SDK to deploy to AKS, or which is Azure Kubernetes Service, which is the production level service, or Azure Container Instance, which is your dev test single node scenario. But you could deploy it to any Docker runtime. So you can export that image, because every time you create a machine learning workspace, you also get an Azure Container Registry. And from there, you can pull that image and deploy it to any Docker runtime you want to. The only difference is when you deploy it in a non-managed runtime, then you are responsible for tracking and doing all those things. If you deploy it in AKS or AKS in particular, we actually manage it for you. So that's the difference.
Is there any plans to support app services as well as a runtime?
I do not know that, but yeah, you could give us a feedback. I'll note it down as well. So, but yeah, right now I don't know.
Good question. Yeah.
Good question. Thanks.
How's it going?
Yeah.
So I'm newer to all of this ML stuff, and I'm trying to conceptualize Databricks. And the one thing I'm getting caught on in my head is treating it as a computing resource, or is that fair to do that, or is it more than just that? I'm just trying to like solidify it in my head. So I guess my question is should I be approaching it as a computing resource, and if so, is there more to it than that?
Okay. So
I think. Do you have some few minutes after this?
Yeah.
Okay.
Yeah, we can talk.
This is a longer discussion.
Okay. All right.
So if I'd love to talk to you about this.
Sure. Yeah. I'll hang around.
Maybe after.
Okay. Yeah. I'll hang around.
We should talk. Yeah.
Most of the time when we say deploy a machine learning model, we are talking about deploying as a web service.
yes.
Right? What if I want to use the model directly in my program, say .NET and the C# program? How can I do that?
Okay. So yeah. So the question is, instead of a web service, if you want to deploy the model as something, so we do support one as a batch scenario. So you can do that, and we also support ML.NET scenario. In that case, instead of using the Python-based SDK which you saw today on Databricks, you cannot use ML.NET with Databricks. You will have to use a different option, but you can deploy it in your .NET environment as well. The same SDK works. And we did I think the launch happened yesterday, so there might be some blogs or there are some talks which I'm aware of. I mean, I don't exactly recall when, but there were some talks during build where we launched ML.NET. So in that case, you can actually even use C# and benefit from whatever we showed you.
Okay, so in that case, I expect the model will be in a scoring file or some kind of format.
Yes, it will be a DLL equivalent of that, and that's how you can get it. Yeah.
In the ML.NET, you are able to use that scoring file and
Yes.
invoke the model.
Yeah. So in fact, even in this one, once the model is deployed as a web service, you are not restricted to Python. You can call this HTTP endpoint from anywhere, from C# or from Java or anywhere, right? So it's independent. But what I was trying to address is if you want to do the training itself in C# instead of Python, we still support it with ML.NET.
Okay, all right. Another question, for all your demo program, are they available on the GitHub?
Yes.
Do you have the links?
Yeah. So I can show that. So The MLflow demo is not on GitHub yet because it's private preview. So that you can access once you enroll in the private preview. But the automated ML demo is there on my GitHub. So this is my GitHub, the URL. This is one. And then we have a lot of notebooks I mean, we publish it in Azure itself. So we publish a lot of notebooks over here. So you see how to use Azure ML. And in that, not only AutoML, but even a lot of other options that are there, everything is published over here. So it's all public, and it's available for you to use. And yeah, and if you go to that Azure Docs link that we showed in the reference, it will also take you there.
There's also a set of notebooks that show other Azure Databricks, Azure Machine Learning integration, which we could not cover in this talk, but it's all.
It's all, yeah. And we keep on updating it all the time. So that's it.
Thank you. Thank you.
Thank you.